Welcome back to the MarkLogic Security Series. In this episode, we're going to take a look at encryption in keys management. To follow along with the exercises in this video, you'll want to have downloaded and installed MarkLogic. You will also want to watch the prerequisite tutorials in this series and complete their associated hands-on exercises. In this video, you will describe encryption and its purpose, describe what information can be encrypted inside of MarkLogic, describe key management concepts, and implement encryption at rest using the PKCS number 11 secured wallet. So what exactly is encryption at rest? Encryption at rest enables you to transparently and selectively encrypt your data residing on disk in your MarkLogic cluster. It can be used if your cluster is running either locally or in the cloud. Because MarkLogic allows data to be encrypted in a transparent mode, this means that MarkLogic files resting on disk are encrypted, preventing access from outside the MarkLogic process while requiring no modification to applications developed on MarkLogic databases. And you can set your options at the cluster level to encrypt data on all the hosts in that cluster, making configuration all-encompassing and easy. So why is encryption at rest so important? Without encryption, or even with file system encryption, the system administrator, hacker, or cloud operator could access or even modify files, including the files that comprise your database. Encryption at the database level eliminates all of these risks because it grants access to data, logs, and configuration files only to users authorized in MarkLogic. Even if those data files are copied to another server, those files would be useless without encryption keys. In addition, by using an external key management system, or KMS, not even authorized users would be able to copy and read data from another host without proper registration of that host at the KMS. This separation of control between the MarkLogic administrator and the security administrator who controls the KMS further enhances the protection provided by encryption. Finally, by encrypting logs and configuration files, not even MarkLogic administrators can delete or modify auditing events in log files, therefore minimizing the ability to erase traces of wrongdoing. Encryption at rest is critical to secure data from both internal and external threats. There are three types of data that can be encrypted. First off, your user data. This is data ingested into MarkLogic databases, along with derived data such as indexes, dictionaries, journals, backups, and so forth. You can also encrypt the configuration files generated by MarkLogic, for example, those that define app server or database configuration. And finally, you can also encrypt log files, and this includes all the log files generated by MarkLogic, such as error logs, access logs, service dumps, and task server logs. Encryption of logs is really important for regulators because it helps prove that everything in the database is tracked and that the tracking mechanism itself hasn't been tampered with by anyone. In total, encryption is comprehensive and flexible. It allows the administrator to choose which databases to encrypt, if configuration should also be encrypted, and if logs should also be encrypted. The encryption algorithm used for data, configuration files, and logs is AES 265, or symmetric encryption. Encryption works with keys generated by MarkLogic or keys generated by an external key management system. A Keystore is a secure location where the actual encryption keys used to encrypt the data are stored. The system that manages keys is what we'll refer to as a KMS. You should note that if you cannot access your KMS, or if you lose your encryption keys, you will not be able to decrypt any of your encrypted data. Out of the box, MarkLogic uses soft HSM to provide an embedded PKCS number 11 secured wallet that you may use as the Keystore to configure encryption at rest. And PKCS stands for Public Key Cryptography Standard. Now this is installed automatically when you install MarkLogic 9. Alternatively, you could choose to use any third-party KMS that conforms to the KMIP standard interface. In this tutorial, we will focus on using the out-of-the-box PKCS number 11 wallet provided with MarkLogic. But if you're interested in integration with a third-party KMS, please check out the Configuring a Third-Party Keystore section in the documentation for more detail. Now let's set up encryption at rest for our James Bond example that we've been working to build. The first thing we need to do when configuring encryption is to think about how we wish to manage keys. In this example, we're going to use the embedded KMS. Encryption key management for the embedded KMS is handled automatically by MarkLogic. Keys are never purged from the PKCS number 11 wallet, and the wallet is protected with a passphrase. The password of the admin user that you create when you initialize MarkLogic is used as the initial passphrase of the KMS, but you should change it. This way you can create separation between the MarkLogic admin and the administrator of the KMS, and you should do this before you configure encryption on your MarkLogic cluster. You'll also want to consider a strategy for rotating keys periodically over time. MarkLogic provides several useful functions for you to use in managing your keys, and you can read more about these functions and see examples of them in the documentation. So let's get started by setting up encryption for a single database that already exists. And if you recall, for our James Bond example that we've been building, we have been using the documents database. So let's open the admin interface on port 8001 and select the documents database. And the first thing you'll want to do is scroll down to find the data encryption option. We can turn encryption on selectively for this database. But remember, we could also turn on encryption settings for the entire cluster. If you have set up cluster-wide encryption and you want this database to use those settings, choose the default cluster option. Since we have not set up cluster-wide encryption settings, let's choose the on setting for the documents database. Also take note of the encryption key ID field. This is used to enter an existing encryption key ID. For instance, if you have an encryption key from an external KMS. The encryption ID field only applies when using external KMS and is optional, so it won't be used in our current example. Let's click OK to make this configuration change to the documents database. Now once your configuration change has been made, let's take a look at the status page for the documents database. In here you'll note that the encrypted size is 0. This is our indicator that the database has not yet been encrypted. When you enable encryption on an existing database, any new data that is written to that database will be encrypted. But to encrypt all of the existing data and indexes, we need to perform either a reindex or a merge. So let's go back to the documents database configuration page and force a merge by clicking on the merge button. Now we can go back to the status page for the documents database. And when the encrypted size value is equal to the size value, that means the encryption of the database is complete. Next, let's take a look at managing encryption settings on our cluster so that we can encrypt our configuration settings and log files. In the admin interface, let's select Clusters and then click the Configure button. And here you're going to notice the data encryption setting. When set to default off, it means that new databases will have encryption turned off, but you can override that per database depending on your needs. When set to default on, it means that new databases will automatically have encryption turned on. But again, you can override that setting per database depending on your needs. And finally, when set to force, that means that all databases will be encrypted, and you cannot override the setting on an individual database basis. Let's go ahead and set our cluster settings to default on. You'll also notice here the settings for enabling the encryption of log files and configuration files. Let's turn each of those to on for our cluster. And finally, you'll notice the settings for key management service. If you select external, you will see that you can define connection settings to your external KMS. You should set up your external KMS before configuring the connection in MarkLogic. For our purposes, we will choose the internal option and use the out-of-the-box PKCS number 11 secured wallet provided with MarkLogic 9. Now that we've selected our desired cluster encryption options, let's click OK to go ahead and save that configuration. And now, as we rotate our log files, any of the new log files that get created will be encrypted. For example, if we were to go out and look at one of our log files, we would now see that that data has been encrypted. In this tutorial, we introduced the key concepts around encryption and keys management. To learn more, please reference the security guide and the Encryption at Rest section in the documentation. In this episode, you learned to describe encryption and its purpose, describe what can be encrypted inside of MarkLogic, describe key management concepts, and implement encryption at rest. Remember that to follow along with the hands-on examples in this tutorial, you can download and install MarkLogic 9 from the MarkLogic developer site. And you can access the code examples that create the database and lead up to this example through the MarkLogic University GitHub site.